Alright, so this video is going to be about how relative velocity affects the impact of storm winds. So what is relative velocity? If we talk about relative velocity in physics, let's say that you're in a car, okay, and that car is moving at a speed of, let's just say 10 meters per second, right? And there's an observer out here on the ground. I'm going to make a reference point out here on the ground like this. Here's the ground. Here's your observer like this. Okay, and they see the car going by at 10 meters per second. And let's say there's another person on top of the car, and they're going to throw a ball. And they're going to throw the ball from their vantage point, they'll put from the car. The velocity from the car, okay, of this ball is going to be, that person's going to throw it at 1 meter per second from their reference point. So the ball, from the velocity of the ball relative to the car is 1 meter per second. But the velocity of the ball with respect to the ground is going to look like it's moving at 11 meters per second to the person on the ground. Okay, so in other words, you have to add up these velocities as they're going to the observer here on the ground. That's what they'll see. Okay, so the same thing occurs in a storm. If you have a storm and it's going towards land, so I'm going to make like a coastline here. Let's say you have, I don't know, let's do like Florida or something here. That's where I live. So Florida. Let's do the coastline. Here's the Gulf. Here's the Keys. I don't know, down here. There's like Cuba down here. I don't know. It's just my crude drawing here. Okay, so there's like Okeechobee. All right. So basically, if a storm's coming like this, okay, and let's say that it's moving to that West Palm Beach area. Storm's coming in like this. The storm's going to have a speed that it moves with. So let's say the storm has a relative speed moving in this direction. And let's say that the speed of that storm is, I don't know, let's say that it's moving pretty fast. Let's say that it's moving at 20 miles per hour. That's pretty fast for a storm, right? Okay, as they get up in the jet stream, they can go, or that higher latitude, they can go even faster than that. But down in the tropics, that's pretty fast. So the velocity would be 20 miles per hour. So let's say that the maximum winds of the storm, max winds of the storm, are going to be, let's say, 100 miles per hour. Okay, so a couple things happen here. First of all, if you're on this side of the storm up here, you're going to get the brunt of the winds here, right? You're going to get that 100 mile per hour wind here. Okay, plus you have to add the 20 miles per hour that it's moving. That's the relative velocity, right? So if there's a person right here on the beach, right? There's a person here on the beach, okay? They're going to feel the velocity of the hurricane, of the winds, plus the velocity that it's moving. So that person is going to observe wind speeds of 120 miles per hour, because it's a relative speed. Okay. Now, what about a person right here? Well, a person right here is going to have, the winds are actually going to be going this way, okay, at 100 miles per hour. So the person down here is going to feel this on the beach. Plus, this forward motion is going to cause that velocity vector just to tilt a little bit this way. So they're going to get a wind basically from the north, but it's going to go a little bit towards the shore because of the 20 miles per hour. The person all the way down at the bottom of the storm, down here, is going to basically see a wind that's going to go offshore. So the velocity down here, let's say that's 100 miles per hour. They're actually going to see an offshore wind of 80 miles an hour. So it's going to be 100 minus 20. So this person's going to see a velocity of 80 miles per hour. But that one's going to actually be going offshore. This one was going to be going onshore at 120. And this one was basically going to be going north, basically from the north, but it just tilted a little bit in towards that person. Okay, Now, how does this affect the storm surge? Well, the person up here, they're going to get maximum storm surge up here on the coast because it's stacking the water up here. This person may get a little bit of storm surge, but basically the wind is going very fast, right? But it's going probably a little bit over 100, but it's moving basically parallel to the coast. This person down here, it's actually going to push the water offshore. They're going to get like a negative storm surge. It's actually going to make the water push out because the wind's going to be going that way. So that's an example of how relative velocity can affect a storm and what happens to the shorelines.